Good morning, everybody. I hope you are ready to another day at the conference, at the International Conference of Innovative Research. Today we will start with the second invited speaker session. And the first guest that will present us an important contribution of the science of material science is Associate Professor Tunde Ana Kovac from Department of Material Technology from Obuda University, Hungary. Dr. Kovac is an Associate Professor in the Department of Material Technology of the Obuda University, Hungary. She is a member of editorial board of the Acta Materialia Transylvania, co-author of 109 publications with around 150 citations. Her research interests are in the field of the material science and technologies, special welding processes, ultrasonic and explosive welding, affected phase transformation of metals, and the research interest of the impact load resistance composite materials. So good morning, Dr. Kovac.
Sorry.
Good morning, I hear you, yes.
Okay, good morning. I open my camera.
Yes, you can open also
Okay,
the camera,
thank you.
maybe.
Good morning.
Good morning, welcome to the conference. And we are very glad to have you together with us in this morning. Wonderful online morning.
Thank you very much.
So please proceed to your presentation.
Thank you very much. Good morning for everybody, ladies and gentlemen. I share my screen. And, oh, no. Okay, it's this is not mine.
Yes, I ask Nicola to remove the share screen, please. Thank you. Someone make some test live.
Okay,
now the screen is yours, please.
Okay. I think, okay. Okay, I hope.
Yes.
Do you see? Do you see?
Yes, I see. Yes.
I have a.
You can start the slideshow.
Okay. That's a. One moment.
Yes. F5. Push the F5 key.
Okay. Okay. Thank you. And okay. I don't know. Do you see my screen?
Excellent. Yes.
Okay. Thank you very much. Good morning, and ladies and gentlemen, I start introduce my research topic: the microstructure changing as a function of the electroacoustic effect under ultrasonic welding process. This is a special welding process, and so we try to find the relationship between.
Just a second, Professor Tunde. I guess you have two screens on the computer, and we see the screen that you should see, not the presentation.
Ah, okay.
You should switch the share screen with the other screen, because this is high resolution.
Okay, sorry. Okay.
Now try to start the slideshow now.
Okay.
And to share the presentation, not the screen that you have to see.
Okay. Okay, that is okay.
Yes, this one, perfect, perfect. Thank you very much.
Thank you. Sorry. So The ultrasonic welding is a new and useful joining process. So when we establish a metallic joint between metal sheets, so this joining by spatial effects, when we use electroacoustic effect and plastic deformation. Also, this process assisted by the friction established heat. So, what are the effects during the ultrasonic welding? So the most important, the electroacoustic high frequency vibration, the plastic deformation, and the friction established heat. We will understand from this process the effects, but we need to talk a little bit about the electroacoustic high frequency vibration effect in the solid metal crystal structure. So it's a lot of research found a relationship between the mechanical and physical properties of the solid metals and the effect of electroacoustic high frequency vibration. You can see in this diagram that if we use electroacoustic ultrasound effect and we don't use it, the stress as function of the strain is different. So that's the name of a Blaha effect, because it was the first researcher, Blaha and Wegenecker, who detected this relationship in the case of poly and monocrystal materials. We can define an equation between the ultrasound induced softening and the intensity of the ultrasound, that is depend on the stress amplitude. We tested face-centered cubic crystal structure material, and I want to introduce this changement on the base of this crystal structure. That is a very simple and well understood crystal structure. And we know we can find always some defect in the crystal structure. A special defect, line defect, is a dislocation. So under ultrasound effect, we can see that the dislocation movement is easier. So ultrasound support the dislocation movement. And also, ultrasound's effect on dislocation density causes a reduction, so that is experimentally observed. Plastic deformation is the second effect during the welding process. That's when we need to understand the dislocation theory. That is the first effect was the electroacoustic effect. Also caused the movement of dislocation, and the plastic deformation caused also a modification by the dislocation density. And you can see in this picture that how the dislocation move in the crystal structure. Plastic deformation theory based on Taylor, Orovan, and Polanyi and other researcher theories, we can see the model of the established half plane or the base of the dislocation movement. And in the second picture, we can see this dislocation in a real transmission electron microscopy picture. What we detected this half plane in the crystal structure. The plastic deformation affect hardening. It's the name of this hardening, the Burke hardening phenomenon. And in the case of this diagram, we can see typical stress strain curve in case of the face-centered cubic metals. we can see the hardening depend on the strain. So we can find a minimal level of the strain what cause the hardening in the case of this face-centered cubic lattice metals. The third part and the third effect in the case of this welding process, the heat. The heat established from friction, the friction from the vibration, and this heat cause thermal stress and thermal effect. It's well understand and know from the research before that the dislocation not thermomechanically stable formation. So the dislocation density depend on the temperature of the metals. We can see in on this diagram that this heat cause softening, even that the cold working cause hardening effect, the heat modify this effect, and the results is a softening and the hardness decreasing during this process. So we can find three different effects that are the most important during our ultrasonic welding process, and this effect cause different modification in the crystal structure and the physical and mechanical properties. So the plastic deformation usually causes hardening, the heat causes softening, and the electroacoustic energy input also causes softening. Base of these effects is the defect in the crystal structure and the crystal structure changement. Okay, the results that we can detect also, that is the dynamic recrystallization and under grain refinement, softening in the welding process. Okay, I would like to introduce some experiments that can show this effects results. We used almost pure aluminium. Aluminium has a face-centered cubic lattice with well formability and plasticity and low tensile strength. So it was well formable material. We used very thin test samples. You can see the setup in this picture. So it was some smaller samples. The used machine, ultrasonic welding machine, was the welding ultra weld machine. The theory of this ultrasonic welding you can see. So we use the force to press the workpieces, the two aluminum sheets together, and vibration transferred by a sonotrode, and the joint between the two sheets established by this pressure force, the vibration, the ultrasound effect, and from this vibration established heat. This is a three effect caused joining between the two sheet atoms and resulted a metallic joint between the sheets. Okay, they used parameters in the case of this process. You can see the trigger pressure. The trigger pressure is the pressure before the real process. welding time was only 1.5 seconds. That is very short and very rapid process. Welding pressure was 40 psi. That is during the welding time used pressure, and the power we used 1016 and 1300 watt. So the two different power to establish the joint, and we compared those parameters results. So the amplitude of the process was 37 micrometers. So the variable parameters that we can change, this is the time, the amplitude, the clamping force or welding pressure, and the frequency. The frequency was constant in the case of our experiments. I showed we used different parameters, but the optimal parameters was showed before in this list. Okay, from these parameters, we can calculate the power and the energy by those equations from the welding force and the area of the welded joint, and the frequency, and also from the power and the time of the welding, we can calculate this results. Okay, we can see in this picture the welded joint. You can see the thin aluminum sheet, and on the surface the joint, and the cross-section microstructure in the right side picture. This is a metallic joint, but without any melting and any mixing between the two sheets. So we can see the border between the two sheet surface. Even that we tell that we established the metallic joint without mixing and melting, but the two sheet atoms joined during this process. Okay, the cross section and the base samples was tested by transmission electron microscopy, and we wanted to see the structure of the dislocation. In these pictures, you can see the dislocation. In the right side, the welding affected zone. So we detected not only in the welded joint, but near the welded joint, the dislocation density changed and increased as a function of this process. Okay, we made a visual inspection of the welded sample. You can see in the right side of wrong defected sample because the deformation was too much and not suitable for application, and the other one is good and suitable about visual inspection. Also, you can see the magnification of the surface, the plastic deformation, the process caused plastic deformation, and below the tensile test results that we made to control the mechanical properties. We can see here the joint was enough strong during the tensile test, and we measured look like same results than the basic material tensile strength. Also, we detected some difference as function of the varying parameters. So we detected not only in the joint, but in the affected zone also caused some changement, the complex effects. Okay, in the joint, we detected some recrystallization. You can see here the grains, the renewed and coarse grains, and the jointed surface borderline. So in the joint, we detected recrystallization under this process. Okay, so the conclusion, during the ultrasound welding process, the created metal microstructure depends on the process effects. So the first effect was the plastic deformation, caused the work hardening phenomenon, and increased the hardness in the metal joint. The other effects, the heat caused recrystallization and softening. So it usually, as function of the established heat, we detected dynamic recrystallization in the joint. The used electroacoustic vibration was constant 20 kilohertz, and we detected also the softening effect of the ultrasound in the affected zone, not simply in the joint, because in the joint we found the complex effects. So the ultrasound effect was measured in affected area. The dislocation area, dislocation density also depend on the effects. So the ultrasound effect and the other. So it need more tests to define the stronger relationship between the ultrasound effect and the dislocation density. So these complex effects establish the special physical properties of metallic joint and the affected zone in the case of metal sheets. So we can conclude that the mechanical and physical properties of the joint and the affected area depend on the process parameters. So the complex parameters effect. So thank you for your kind attention.
Thank you very much, Dr. Kovac, for your wonderful presentation, which has actually an applicative paper. So I see on the chat room some question for you. I moderate these ones. First one, how important is the amplitude values? Is there a critical, minimum, or maximum value? First question.
Okay, so it's amplitude value is very, very important because the established heat depend on this amplitude. So usually the optimal amplitude depend on the metal. So in the case of copper or aluminum or steel, we need to use a little bit different amplitude. Our test showed that is a 37 micrometer was suitable to establish a joint and didn't cause high temperature. So in the case of a critical amplitude, So the maximal is a 60 micrometer in the case of welding machine. So it can cause melting. That is not suitable in the case of this process.
Yeah. The second question, actually from the same professor, Doru Burduhos, is can this method be applied for other type of metals?
Yes, we made many experiments. So it's very useful for copper, aluminium, and also mild steels. So it depends of the plasticity of the metals. So it's a very high strength metal. In the case of very high strength metals, is not suitable. So it's usually for high plasticity metals is very useful.
Thank you. And the third question from Professor Nejneru. Do we need the same heat treatment after the weldings? Is it necessary to intensify the diffusion?
Okay, we made some experiments to preheat or after heat treating, after the joining, some heat treatment, but it's not necessary usually. And this is a very rapid process. And about industrial application, this is very good because the process time is very short. So without any preheating or post-heating, it's not necessary.
Thank you. Any comments? No. Last question from Professor Semenescu. As I saw in your presentation, the tests were done on plate sheets of aluminum. It may be applied for angular plates.
Yes, it depends on the machine. So it can prepare liner welding also if we use different anvil, and it can do it.
Thank you very much for the presentation. Thank you very much for the answers. And on behalf of Scientific Committee, which are appreciating your efforts to deliver such a high quality of presentation, we offer a token of appreciation. Professor.
Good morning. As a token of appreciation, we have the certificate for invited speaker that you will receive with the package that will be sent after the next week. And also next to this, we have the token of appreciation as innovation ambassador. This genuine leather diploma, it's unique and original because we are in the innovative field, so nobody did this before. This is one kind of diploma. Congratulations again.
Great pleasure for me. Thank you so much.
Thank you very much for your contribution to the conference. Next invited speaker is Shaiful Zamrei Abdrahim, which is an associate professor, PhD, at the School of Manufacturing Engineering from University of Malaysia, Perlis. He is also a corporate member of the Institution of Engineers Malaysia. He has published over 150 articles with over 600 citations and the Hirsch Index 16. His research interest is in material processing, injection molding, optimization, and product design engineering. So good morning, Shaiful. Can you hear us?
Microphone, please.
Thank you, Mustafa.
Open microphone, please, Mr. Professor.
Great.
Good morning. Can you hear?
Good morning. Excellent. Please.
Hi everyone. Are
Hi.
you hear me,
Yes.
Prof?
Yes, we see you. We have prepared already or record the presentation. And you ask us to make a short intro.
Okay.
We have 2 minutes.
Okay. Thank you, Prof. Hi everyone. I'm Saiful from School of Manufacturing Engineering, University Malaysia Perlis. Hope all of you in a good condition, especially in unprecedented and difficult time of COVID-19. Firstly, I would like to say thank you very much to organizer international conference, Innovative Research each year 2020 for giving me this great opportunity as invited speaker in this conference. So I'm glad to share my current research and looking forward for any kind of collaboration. Due to my internet coverage at my area not so good, so I have provided a video presentation. Hope all of you enjoy and please contact me back if you have any clarification. Thanks all. Keep safe. Stay safe.
Thank you. See you after the recorded presentation to final question if there are any question. Okay.
Hi everyone, I hope all of you are doing well in this unprecedented and difficult time of the pandemic COVID-19. Firstly, I would like to say thank you very much to the organizer, International Conference on Innovative Research, ICIR 2020, for giving me this great opportunity to share about our team research on potential of metal epoxy composite, MEC, as hybrid mold insert in rapid tooling application. Before that, I'm Saiful Zamri Abdurrahim from School of Manufacturing Engineering, University Malaysia Perlis, Malaysia. This is my presentation outline today. The economy of most countries in this world largely driven by the services and manufacturing sector. The manufacturing sector contribute about 22.8% to gross domestic product in year 2018. Injection molding process is a part of manufacturing sector and widely used to manufacture plastic product in various type and application. The demand for short time delivery of low-cost product with various geometrical shapes are increasing due to the rapid design changes of consumer product made from plastic, rubber, and elastomer. Okay, figure A shows the conventional method to produce the mold for plastic injection molding process. It starts with a CAD model design and then mold design. After that, the fabrication of mold inserts, which involve many types of machining process such as CNC milling, drilling, EDM, electrical discharge machining, wire cut, and others. And then we will get the plastic parts, and then this plastic part will go for the secondary process such as painting, plating, and so on. On the other hand, figure B shows the several types of rapid tooling technologies, such as metal epoxy mold, 3D printing ABS mold. 3D printing ABS mold is only the we fabricate the mold insert using 3D printing ABS mold, but the mold base is remain still. And another one is a silicone rubber mold. Rapid tooling, as we all know, rapid tooling offers a cheap, fast solution, encountered some limitation of market size, such as a small batch production and custom product. So in this research, we focus on replacing the material to fabricate insert, which normally fabricate using P20 steel, replaced with metal epoxy composite mold. The challenges is a limited resources of literature, limited tooling material in terms of type, size, and shape of fillers. And another one is epoxy itself, which are low material properties. Okay, now we go to the literature review. From previous researches have been done, there are several issues that need to be considered before fabricate mold epoxy composite as a mold insert for injection molding process. The first one is the filler particles. In terms of type of particles, grain size, and the shape of particle used. The second one is the trend result of metal epoxy composite properties testing. The third one is the effect on shape of filler particles. And then the hybrid mold or mold insert. And the last one is sample preparation. Okay, now we go to the researches on fillers particle. From the previous study have been done by previous researchers, what we have found that most of researchers use aluminium, brass mixed with copper, copper mixed with aluminium, nickel mixed with aluminium, aluminium mixed with alumina, silicon, and nickel as the filler particles in their research. Most of researchers use between 0 to 60% of percentage of filler composition in their study. 60% is the maximum percentage, because if more than 60%, the compound, the mixing of epoxy with the filler particles cannot pouring into the jigs during the casting process. About the grain size, most of researchers use between 0.4 to 150 micron, and most of researchers conducted this type of testing includes thermal conductivity, hardness, tensile strength, wear test, compressive strength test, density, and microstructure. So in our study, in order to develop the metal epoxy composite as a mold insert for injection molding process, thermal conductivity and the compressive strength are very important. Okay, based on graph A, B, and C, density, thermal conductivity, and hardness tests have indicated a similar trend, which shows the uptrend behavior. When the percentage of filler composition increase, the value of density, thermal conductivity, and hardness will be increased. Okay, based on these three graphs, it can be seen that the compression test indicate a non-linear trend. By adding composition of filler particles at 10 to 30% is the range of highest compression value, and it is useful for extending the life of the epoxy mold. However, the value drops gradually when adding more than 30% composition of the filler particles. Okay, now we look into the wear rate test and tensile test. Wear rate test shows the value start with the highest wear rate, and then when increasing the filler ratio, the wear rate decreases continuously until a certain percentage of filler ratio, then where it start to increase again. On the other hand, tensile test shows the value drop gradually when adding the filler particle into the epoxy matrix adversely affect the tensile strength. The unfilled particle into epoxy matrix shows the higher tensile strength as compared to the adding filler. This figure shows the summary trend of material properties testing. As we can see here, the green color is tensile test. The yellow color is wear test. The black color is compressive strength test. And the purple color represent the thermal conductivity, density, and hardness. Most of researchers use the percentage of composition between 10 to 30% of filler particles as mold insert. However, this composition rate is used by manufacturers who produce an epoxy aluminum resin. In addition, by adding filler more than 60% percentage of filler composition, the mixture will become too viscous and resulted more porosity, poor surface roughness, and the material become more brittle. This figure shows the effect of filler-shaped copper powder on the thermal conductivity, with the composition short fibers between 0 to 30%, plate and spears between 0 to 60%. As we can see here, the thermal conductivity is increased by the addition of filler composition. Three types of copper fillers are scattered at 10% of filler composition. The thermal conductivity for copper fiber fillers are increased rapidly by using copper fiber fillers as compared to the plate and spears. Okay, now previously in the range of composition 10 to 30% of filler particles, it can reach the highest compression value. And now the most important finding that we can see by using fibers fillers particles can rapidly increase the thermal conductivity. Okay, based on the review has been done, it has been found that the thermal conductivity on the metal epoxy composite are still low, reported by all researchers as compared to the conventional metal used as to fabricate the mold insert, such as P20 steel and aluminium by using SLS technology. And this low thermal conductivity will result in the poor cooling time. However, a few researchers use various types of cooling channel to reduce the cooling time, but the cooling time is still higher as compared to the conventional metal, as compared to the mold insert fabricated by using conventional metal, P20 steel and aluminium. Okay, now we go to preparation of MEC specimen. Normally, the preparation of metal epoxy composite specimen will start with the mixing material, epoxy, hardener, and filler particles. After mixing, the mixing will be stirring, and normally between 10 to 15 minutes. After that, degassing to remove air trap normally take time between 10 to 60 minutes. After that, the mixture will pouring into the rubber mold. And the last one is the curing process up to the maximum temperature suggested by epoxy manufacturer. Different epoxy, different temperature for curing process. And degassing is most important factor to reduce the void and improve the epoxy matrix structure. Okay, from the review have been done, a few research gaps have been identified. The first one is majority of researchers study applied aluminum fill epoxy and using spherical shaped particle. Only HSTC use the plate and fiber particles, and they reported a good finding on thermal conductivity, but not applied as a mold insert application. They applied on the others application. Another one is optimization was conducted by researchers for preparation, process, and analysis injection molding parameter setting. From the review have been done, a few potential future works have been identified. The first one is about the filler material. We can mix filler material between brass and copper by using different type of shapes. The second one is design of experiment. We can apply to determine the significant factor that influence in producing metal epoxy composite material. There are many types of DOE we can use. We can produce a large number of paper here. Then the third one is develop mold insert using newly metal epoxy composite material with cooling channels. And the last one is we can conduct experimental works and compare to the simulation studies in terms of cooling time, number of cycle, and quality of molded part produced, such as shrinkage and warpage. Here also, we can apply DOE. Again, a large number of paper can be produced here. Okay, these are the problem statement has been identified. The main issue relating to the development of metal epoxy composite for molding application and processing are poor mechanical properties. The second one is low thermal conductivity, which is a slow heat transfer out from the molded part to the mold insert and to the cooling channels. Next is limited quantity of production due to crack and wear because of friction during mold opening and part ejection. Next is design constraint in molded part, such as rib and thin wall that can break the epoxy inserts during processing. Next is part quality in terms of dimensional and molded part defect, such as shrinkage and warpage. And the last one is the constraint in injection molding parameters, where high injection pressure and high melt temperature setting can affect the wear and crack on the metal epoxy composite after many cycles. From the review have been done, A few research questions have been identified, such as how does the various filler particle affect the metal epoxy composite mold insert for injection molding application? What is the appropriate ratio of filler particle that can extend the performance specifically for thermal conductivity and life of the mold insert from a combination of type and shape of particles? Can the metal epoxy composite mold insert be developed using a rapid tooling techniques by getting acceptable mold part with improved quality in terms of dimensional and strength? And the last one are the simulation result of more performance in line and similar to the experimental result. To answer all of these research questions, a few research objectives have been set. Our aim is to apprise new formulation of metal epoxy composite material for the mold insert in injection molding application and rapid tooling for non-metal product. Okay, that's all from me. If you have any question or anybody interested to collaborate, any type of collaboration on this project, please feel free to contact me through this email. Thank you very much for your attention. And again, thank you very much to Organizer International Conference on Innovative Research, ICIR 2020. Stay at home, work from home, we care, stay safe. Thank you very much.
Thank you very much, Saiful, for your wonderful presentation and for important contribution for this kind of material that you add to the material science. Also, we have here a question that you try also to answer in the chat room, but I must to hear by everybody. The particle dimension can influence the thermal conductivity of the mold, please.
Yes, from previous researchers, we have found that they have reported that the size and shape of particle will influence the thermal conductivity of metal epoxy composite mold. But we still we haven't tried yet. We in stage of finish doing literature, and we will test soon. But from previous researchers, yes, the shape and size of the particle will influence the thermal conductivity of metal epoxy composite.
Thank you. Understood. Also from Professor Mihail Tsutsu from Lucian Blaga University of Sibiu from Romania. He
Saiful, you can read the chat box and you can answer from Professor Mihai Titu. The question.
Okay. Now we will continue our research to improve to increase the thermal conductivity and compressive strength of metal epoxy composite, so we can replace the P20 steel as a mold insert, especially to produce plastic product in injection molding for rapid tooling application.
Okay. Thank you very much. Also from Professor Mihai Axinti from our university, is there a question? Thank you for the presentation. How do you control the homogeneity degree? It can be improved?
Just like I said just now, we at the beginning of the research, and we only just finished doing a literature review. And thank you very much for a good question. We will look on that after this.
Okay. Also,
Thank
if
you.
you want to continue some cooperation, you can pick up the contact of the participant from the conference, from the book of abstract, or from the web page of the conference. You can start some cooperation with some of them. Thank you very much for your presentation, and on behalf of Scientific Committee, which are appreciating your efforts to deliver the study, high quality presentation, we offer a token of appreciation. Professor Andrei, please.
As usual, each invited and keynote speaker receives a certificate of appreciation. This is on your name. You'll receive the package next to the materials of the conference. As I mentioned before, we have also a special token made from genuine leather, copyrighted at Euroinvent. This is for your office innovation ambassador. And thank you very much.
Thank you very much.
Congratulations once again for the presentation. See you next year or next years in Yash, I hope.
Yes, next year, hopefully I will be there physically. Thank you very much.
We hope that. Thank you. Now we move further for session 3 with first paper entitled Instrumental Techniques for Architectural Heritage Materials. Is a recorded presentation by Rodica Mariana Ioan.
My paper is entitled Instrumental Techniques for Architectural Heritage Materials. First of all, I would like to mention a few words, which means different types of cultural products produced as a result of human creative activity of different kinds, from arts and crafts to sophisticated technology. Cultural heritage includes monuments, groups of buildings and sites of cultural value as it is defined in the article number 1 of the World Heritage Conservation. All the monuments support weathering processes as follow: physical or mechanical weathering to the freeze-thaw processes, also chemical weathering due to oxidation, hydrolysis, and carbonation processes, and also biological weathering due to the microbial population present there. The main cultural heritage deterioration forms could be chromatic alteration or cracking, loss and exfoliation, alveolization, efflorescence, blistering and disaggregation, exfoliation, decohesion, and detachment. Our group has a good expertise to monuments from different parts of Romania, from the western part, for example, Corvin Castle, to the eastern part, for example, Constanța Casino or Adam Clisi monuments, or even Basarab Molfatlar Chalk ensemble. Corvin's Castle is one of the most beautiful 10 castles from Europe. It is known as Huneadi Castle too. It is located in Hunedoara area, region of Transylvania from Romania. Has been built in 15th century on the site of an older medieval fortification on a cliff above the Slash River. It is located in the western part of Romania. The Corvin Castle has 8 towers, defense towers, most of them, as could be observed in the following picture: from Mace Tower, Drummers Tower, Old Gate Tower, Deserted Tower, White Tower, Nieboisa Tower, Capistrano, and also Newgate Tower. In the paper from today, I would like to present you some analytical investigation results of Old Gate Tower. You could observe in the in this slide, the location of this old gate tower and also the samples collected from this by infrared spectroscopy with Fourier transform. It was possible to put into evidence the presence of quartz, also feldspar, calcite, and different sort of apatite. By optical microscopy, it was possible to put into evidence the presence of iron oxides present here, and also the degradation form of different masonry by scanning electron microscopy. By EDS, coupled with scanning electron microscopy, was possible to put into evidence the main element present here. So elementary analysis could be observed aluminium, silicium, potassium, calcium, iron, and also magnesium. For all this investigation, we use also transportable equipments, as could be observed here. So ultraviolet visible spectrometer, optical microscopy, also equipment for putting into evidence the corrosion present there, and also mobile equipments for different investigation as mobile, portable, palm, and handheld. You could observe here all this. They are present in our laboratory and useful for put into evidence the temperature, also anemometer, so wind rate, different type of humidity present on the surface or inside of the wall, and also corrosion. The Roman mosaic edifice is considered the most important archaeological jewel of Constanța, built in 6th century after died during the reign of Emperor Constantine the Great. The building connected the port to the city. Originally covered 2,000 square meters of mosaic, but today only 850 remains preserved today. The analytical investigation that we made here, including different techniques from infrared spectroscopy, scanning electron microscopy with EDS, also optical microscopy, as you could observe in this in the left side of the slide, and by EDS from scanning electron microscopy, it was possible to record to perform the elementary analysis, and the main elements being sodium, magnesium, aluminum, silicium, phosphorus, sulfur, chloride, and potassium and calcium. Calcium is one of the most important elements, and also oxygen, and all the other elements offer us the composition and also the structure of the samples collected from this monument. By neutron tomography, for the first time for this monument, we put into evidence the calcite face in green area, and also the red area being the quartz at the top of the slide, and also on the other part of the slide was possible to put into evidence calcite face in blue, and also the green yellow region, hydrated or other hydrogen access on mosaic fragment. The other monument was Adam Clisy monument, which covered ruins of the Triumphal Monument and the fortress of Tropeum Traiani, located in the present at the city Adam Clisy, Constanța County in Dobrogea. By infrared spectroscopy, it was possible to put into evidence the main chemical groups as carbonate, silicium, sulfate, which offer us, in conclusion, the composition in calcites and also silica present here. Is a limestone which covered the monument. Also by X-ray diffraction was possible to put into evidence calcite and quartz and also graphite. Not so important the other. We could conclude that the analytical techniques used for different artifacts from monument show us the value of different samples collected from the monuments, the stage of the degradation and weathering processes that monument supported, and also we could conclude that infrared spectroscopy, Raman, different X-ray techniques, nuclear techniques, XRF, XRD, neutron tomography, and also the microscopy techniques could offer us information about structure, composition, and morphology. And not in the last time, we have different results about gas chromatography with mass spectrometry for the chemical composition, the very fine composition of the samples. Analytical techniques are vital for conservation and restoration of cultural heritage. I would like to thank for your attention and also to thank to the Research Ministry for the financial support that offer us by the project 5.1 of complex projects. Thank you.
Okay, thank you for the presentation. I saw that there are not questions in chat room that must be sent to the author of the presentation. We move to the next presentation entitled "The Effects of Solid to Liquid Ratio on Fly Ash-Based Lightweight Geopolymer," which is a recorded presentation by Wan Mastura, Wan Ibrahim.
Good morning to everyone. My name is Wan Mastura binti Wan Ibrahim, and I will present my paper entitled "Of the Effects of Solid to Liquid Ratio on Fly Ash-Based Lightweight Geopolymer." I will go through my presentations today by starting with some introductions about the geopolymer, lightweight geopolymer, and also lightweight concrete. So I will proceed with the problem statement happen, the objective of this study, the methodology of this research, the significant findings, the novelties of this study, and last is the conclusions. So let me introduce a bit about the geopolymer. The geopolymer is a chemical reactions between the aluminum silicate reactive material with strong alkali solutions. So the geopolymer can exhibit a wide variety of properties in various applications, including the building construction materials. So the geopolymer also have a capability to form at low temperature as low as 40 degrees Celsius with excellent mechanical properties as compared to the existing materials. So what is the lightweight geopolymer? The lightweight geopolymer could be produced either by using the air entraining agents or by using the lightweight aggregates. The lightweight geopolymer is one of the alternatives for construction materials to improve its mechanicals and also their thermal properties. The lightweight geopolymer have a safe operational energy due to its relatively lower thermal conductivity, which can reduce the indoor temperature variations. So the lightweight concrete is represent the alternative construction materials to improve the properties and thermal efficiency in a building developments. So they have two examples of lightweight concrete available in the market, which is the cellular lightweight concrete, as we know as the CLC, and also the aerated autoclave concrete, which is we know as AAC block. However, these two types of the commercial lightweight concretes have some limitations. For example, the AAC block, they are using a chemical forming agent, which is the aluminum powder, but they are produced low strength because of the density were reduced, and they are also have a moderate thermal conductivity. for the CLC block, the cellular lightweight concrete also have some limitations. With they produce the low strength, longer curing time by using the water curing, and also they are using steam curing, which is a higher temperature using. And the lightweight clay bricks, they are using high temperature curing, produce low thermal conductivity, and they are using more than one type of forming agent. So why we have to study these types of the lightweight geopolymer? Because they have some problems happens in the market, which is the normal bricks have a density range between 1,000 to 700 kg per meter cube to 2,000 kg per meter cube, result to high load on the structure. So the second one, because the existing lightweight bricks are using forming agent, produce low density, which is between the 800 kg per meter cube to 1,400 kg per meter cube, but they are produce porous strength, which is between the 3 to 7 megapascal. The third one, because the manufacturing of the AAC block and CLC block require longer curing time and high energy consumption, which is they are using the high temperature between 190 degrees Celsius to 210 degrees Celsius, and they are curing using the water curing, which is consumed 2 to 3 weeks of curing process. And the fourth one, because the thermal conductivity produced by other lightweight concrete is low compared to the lightweight geopolymer. So the objective of this study is to determine the effects of different solid to liquid ratio on fly ash-based lightweight geopolymer. And the second one is to investigate the mechanical properties and the microstructure properties of the fly ash-based lightweight geopolymer at different solid to liquid ratio. So this is the methodology involved in this research, which is we are using the type class F type of fly ash as a source materials combined with the alkali activator, which is the combination, the mixtures of the sodium silicate and sodium hydroxide solutions. And the fly ash mixed with the alkali activator to form a geopolymer paste. Then I will prepare the forming agents with the ratio of water to foam is 1 to 10 by volume, and the ratio of foam to geopolymer paste is 1 to 1 by volume. Then the forming agents were mixed with the geopolymer paste to form the geopolymer lightweight, and then the samples were cured in the oven for 80 degrees Celsius for 24 hours in the ovens. And then the sample after the curing process, the sample were left at room temperature for 7 days until the day of the testing for the mechanical and microstructure testing. The testing for this research involved the compressive strength, the water absorption test, the density test, and also the microstructure test by using the scanning electron microscope. So the significant findings from the research for the results of the compressive strength of lightweight geopolymer, I have found that the optimum solid to liquid ratio is the 2.5 by mass, which is the highest strength is detected at solid to liquid ratio of 2.5 by mass with the value of 90.3 MPa, while the lower strength is observed at solid to liquid ratio of 3.5 by mass with the value of 12.1 MPa. So this is because the highest compressive strength is found to be at solid to liquid ratio 2.5, because it has the optimum amount of the fly ash and alkaline activator that give a good workability and activate the fly ash at the highest rate of the geopolymerization process, and also they will provide the sufficient silica species and rise the ratio of silica to alumina. We can see that the ratio of 2.5 have a optimum value of solid to liquid ratio, because the change in the alkali activator content will affect the silica species content, and also the sodium ions content and base water content. So these all the ratios give the effects to the compressive strength of the lightweight geopolymer. Okay, for the water absorption of lightweight geopolymer, we can see that the lowest water absorption is found at the solid liquid to ratio of 2.5 by mass with the value of 6.08%, while the highest water absorption is found to be at solid liquid ratio of 3.5 by mass with the value of 11.61%. As we can see, at a higher foam value, the merging of the bubbles produce larger voids that result in a wide distribution of the void size, and also we reduce the strength and the water absorption. Okay, so the reason is because the increasing volumes of foam, which can see that the more interconnected pores which are benefit for flow of the water appear, which increase the water permeability and also the water absorption. So for the finding found in the density of lightweight geopolymer, we can see that the density vary in the range of the 1,307 kilogram per meter cube to 1,000 to 800 kilogram per meter cube. So the highest density is found at the solid liquid ratio of 2.5 with the value of 1,375 kilogram per meter cube, while the lowest density were observed at the solid liquid to ratio of 3.5 by mass with the value of 1,267 kilogram per meter cube. This is because the mass of the fly ash is more higher compared in the ratios of the 2.5 compared to the activator, which means less liquid is inadequate in the paste. So therefore, to improve the workability, the more volume of foam is added in the paste. So because the increase of the voids in the geopolymer samples due to the foaming agent will reduce the density of the samples. So increase the foaming agent volume will reduce the density of the samples. Okay, so this is the results of the microstructure of lightweight geopolymer. As we can see, the microstructure of lightweight geopolymer shows some unreacted or partially reacted of fly ash particles, and micro cracks are also observed, which could reduce the strength of the lightweight geopolymer. And we can see from the figure, the micro cracks will also contribute to the lower strength by increasing their water absorption and also the porosity. So the lower values of the compressive strength of lightweight geopolymer was attributed to the presence of voids happen when we cure in the ovens. So this might have resulted due to the poor surface structure of the lightweight geopolymer, as we can see from the microstructure. So from this research, I have found 3 novelties, which is the first one, we can produce the lightweight geopolymer with a strength in accordance to the standard, American standards, with 80 degrees Celsius of curing temperature. The second one, we are using the foaming agent with a low cost and easy to process. And the last one, we can produce the lightweight geopolymer with sufficient amount of solid to liquid ratio. With the highest strength produced is 90.3 MPa, the lowest percentage of water absorption at 7.114%, and the density at 1,373 kilogram per meter. So there is some knowledge contribution from this research. The first one, the admixtures usually used in a concrete could be prepared as a foaming agent to reduce the density of the concrete measuring units. So the second one, the geopolymerization method could produce a better strength for lightweight concrete measuring applications. The third one, the lightweight geopolymer required low curing temperature compared to the conventional lightweight. So last but not least, as a conclusion, I have found that the optimum solid to liquid ratio for the lightweight geopolymer was selected at 2.5 by mass due to the higher compressive strength obtained. And the second one, I can conclude that this ratio caters the highest compressive strength of 90.3 MPa, lowest percentage of water absorption at 7.114%, and the density at 1,373 kg per meter cube of lightweight geopolymer. So last is a big appreciations to the Center of Excellence Geopolymer and Green Technology, University Malaysia Perlis, Malaysia, Faculty Engineering Technology, University Malaysia Perlis, School of Materials Engineering, University Malaysia Perlis, and for the funding research grant scheme (FRDS) for this project. Thank you so much for your attention.
Thank you for the presentation. I saw that there are no further questions in the chat room. So we move to the next presentation entitled Landfill Waste Fire Effects over Town Areas and the Rainwaters. The presentation made by Juliana Cocean. Good morning, Juliana.
Sorry, I forgot to unmute the microphone. Good morning and hello again to everybody. Again from Professor Silviu Gurlui's laboratory. And I'm saying that because yesterday I presented another study that we had in our laboratory. I'm trying to share the screen.
Yes, please.
Okay, and let me know if it's okay.
Yes, excellent. You can proceed, please.
Okay, so if yesterday I spoke about laser-induced dyeing on textiles, on hemp fibers, today we will move into environmental investigation based on alerts that come as pollution episodes are noticed. So, doesn't work? Okay. The alert was in Horezu neighborhood, and it referred at rainwater of dark brown color that persisted few months after a landfill waste fire took place. That denoted extremely high contamination and, of course, inducing damages to the environment. Starting from the effects of open fires and waste incineration in mills, one of the known effects is producing chemical compounds with carcinogenic effect like dioxin and furans, but also emissions of very dangerous chemical species due to their toxic effects such as cyanides and cyanides, including hydrogen cyanide. These emissions result in forest or vegetation wildfires. We already published about this noticed effects and measurements in with LIDAR system in our laboratory in the atmosphere, and we noticed the circuit, pollution circuit, through mainly through the rain as vector of pollutant transmission from the air to the soil and water, and then by evaporation goes back in the air. So mostly the volatile components are susceptible to enter into this dangerous circuit of pollutants. The investigation. As we suspected that the color and the smell of the rainwaters collected from Horezu area, or due to the landfill waste fire, we made few experimental simulations burning different mixtures of materials. One of the simulation of burning was consisted in polystyrene, wool, cardboard, wrapping foil for elements, cotton, plastic, paper, wood. The second one was everything that's in the first simulation minus polystyrene plus polyacrylonitrile, leaves, pectin, detergent, earth. And a third simulation consisted in the second simulation plus aluminum foil, because this is what we expect that people throw in the garbage. And FTIR results proved that the sample of collected rainwaters from Horezu looks very similar with the simulation 2 and 3 burning simulation. And now the interpretation of the bands found on each of I mean, they are similar on Horezu and the simulation 2 and 3. So here we have the bands as they were noticed, as they resulted from Fourier transform infrared spectroscopy. And we noticed aliphatic and aromatic, also heteroaromatic specific bands. And together, so if we consider the aromatic bands together with specific bands for dioxin and furans, it results that they are present in the sample of rainwater. And combustion sources for dioxin and furans could be cardboard paper, food wastes, other materials with aromatic phenolic structures. Also, based on the heteroaromatic bands that we already presented as determined, pyrrole groups have been measured, and also pyridine. And they result from combustion of plastics, dyestuffs, detergents, polyacrylonitriles. Other groups, other functional groups that were detected are imines, oximes, sources in leaves combustion. And if we notice that the leaves are present in simulation 2 and simulation, I'll go back a little bit to show you. So leaves are in the burning simulation 2 and simulation 3. They are not present in simulation 1. And that provides also a difference between S1 and S2 and S3. Okay, then sulfoxides and sulfones sourced in detergent, bleachers, thiols and sulfides, cyanates and cyanides, which result from wool combustion, polyacrylonitrile, and organic dyes combustion. I want to make a mention that also a detection of hydrogen cyanide was noticed, I mean, was made with a sensor, gas sensor, because it's known that hydrogen cyanides at about 25, 26 Celsius degrees would change the phase state from liquid to a gas. So depending on the temperature would allow the vapors to leave the water, and we can detect with the gas sensor. Otherwise, they will stay in the water, and we could get these results on Fourier transform infrared spectroscopy. Epoxides, peroxides, formates, and benzoates were also detected. The sources are from combustion of textiles, wool, polyacrylonitrile, cotton, processed wood, plastics, and detergents. The comments, the discussions based on the FTIR spectrum provides the information that the sample horizon reflects the combustion of waste, like in the simulation 2 and simulation 3, because of the similitude of spectrum, and because of the imines and oximes that are detected in horizon sample and in samples S2 and S3, they resulting from leaves combustion, and in the two simulations, simulation 2 and simulation 3, we used leaves, while in the simulation 1 we didn't use. Also, the pyridine, that's also only in simulation 2, simulation 3, and horizon sample, denotes polyacrylonitrile combustion. That means that I mean, what we want to evidence with these simulations and this compared analysis is that the source of pollution into the rainwaters of horizon is the landfill fire. It's from the waste that were accidentally or by purpose incinerated on the field. And among the pollutants, a high concern is on dioxins, furans, and cyanides. Of course, hydrogen cyanide of very high toxicity that could have effects on the immunity system, producing also skin lesions, carcinogenicity, and other effects on human health. Of course, the other pollutants are also contributing to the low quality of the environment in the area after such episode. We also performed laser-induced fluorescence, and we know that fluorescence in water denotes other substances dissolved or dispersed into the water. So the fluorescence in the water denotes how high the pollution is. And leaf spectra proved the presence of fluorophore aluminium linked to organic compounds, but also compounds of biological origin like chlorophyll, wood lignin, organic pigments and dyes of biological or synthetic origin. Also, the presence of furans is noticed. This high fluorescence noticed on the samples of water from Horezu denote the high pollution more than when compared the spectra, fluorescence spectra of Horezu with the curcumin, which is known for its very, very high fluorescence. That provides worry about the quality of the environment in the area. And here I reiterated the effects on human health for all the chemical components found in detected in the Horezu waters. And the conclusion is that combustion of mixture of materials of high variety of chemicals have a significant danger potential to the human health, and persisting toxicity in the atmosphere and soil, recycled by rain and evaporation phenomena, are inducing long time pollution effects in the environment.
Okay.
Yeah.
Okay. Thank you for your presentation. We have a question in the chat room.
Yes, please.
From Professor Brandusha Slusher from Technical University of Iași.
Okay.
From Faculty of Engineering for Chemistry, Chemical Engineering. It seems like all population is exposed to very high toxic pollutants and carcinogenic as well, where there developed deeper studies that approach impact on health hazards, of course, based on medical database. How was measured the human health hazard or impact?
We didn't do that. We only measured, we only collected the samples of water and did these measurements. It's a beginning of the study, what we presented. Because we did measurements in the atmosphere. We did measurements on spring waters or, you know, different like rain waters, but such high concentration in pollutants and dioxin and furans, we've never met again. So to answer the question, for the moment, no, we haven't measured the impact on the human health. We just used the literature on that, and we are continuing to do this study, the research with.
Thank you for the answer. Maybe next project you will apply and get some money to have all devices that you need for that one.
Thank you. Thank you for the question.
Thank you very much. Thank you very much for your presentation, for the answer. And we move on to the next presentation, which is entitled Weight Distribution in titanium thin silver copper composite lead-free solder subjected to thermal etching using acoustic microimaging technique, which is presented by Nur Shahira Mohammad Zaimi. Good morning.
Open my presentation first.
Okay. Good morning.
Okay.
Yes, please start the slideshow.
Okay. Yeah, hello everyone, and a very good morning to people in Romania, and also good evening to people in Malaysia. My name is Nur Shahira binti Muhammad Zaimi, and I am a PhD student.
Shira.
Yeah?
Slideshow, please. Slideshow.
Okay.
Thank you, Mustafa. Thank you.
Welcome.
Okay.
Very good.
Okay, my name is Nur Shahira binti Muhammad Zaimi, and I am a PhD student in materials engineering from University of Malaysia, Perlis, Malaysia. And first of all, I would like to thank to the organizer for giving me an opportunity to be part of this conference. And then today I would like to briefly explain about my PhD study, which entitled Effect of Geopolymer Ceramic Addition Properties to the Properties of Thin 3.0 silver, 0.5 copper, or we can call it as Set305 lead-free solder. Okay, and this project had been supervised by Associate Professor Dr. Muhammad Arif Anwar Muhammad Saleh, which is one of our keynote speaker yesterday, and also Professor Dr. Muhammad Mustafa Al-Bakri Abdullah. Okay, without further ado, let's start. Okay, this is my presentation outlines that consists of 6 parts, which firstly is introduction, second problem statements, then research objective, methodology, current findings, and lastly is conclusions. Okay. Firstly, what is actually a solder? Solder is a metal alloy that is used to form metallurgical joining during the soldering process. And as you can see from this figure, this is a printed circuit board that have many small electronic components that attach to this board. And to attach these electronic components, we need a solder. So the bonding action is done by melt the solder materials and allow these melt solder materials to flow and make contact with the components that need to be joined. Okay, so a long time ago, people, especially in electronic industry, they use thin lead as thin lead solder alloy as the main solder materials. However, the usage of lead was banned by environmental law, which is RoHS, Restriction of Hazardous and Substance, and also Waste of Electronic Equipment Directive. This is because lead itself is very, very harmful to human health and also to the environment. So, alternatively, solder that are free from lead, or we can call it as lead-free solder, was introduced. And one of them is tin, 3.0 silver, 0.5 copper, or we can call it as Set305. And this Set305 is widely used in electronic industry, and it also has been suggested by National Electronic Manufacturing Initiative as one of the solder material for the reflow soldering process. And however, this Z305 having some drawbacks, and which I will explain later, and this drawback can reduce the reliability of this lead-free solder. So, in order to increase the reliability of this lead-free solder, we can use these two methods, either by alloying method or by composite method. But for my study, I will focus on forming composite solder in order to increase the reliability of the lead-free solder. Okay, so composite solder is actually when we intentionally adding reinforcement, which is either extrinsic reinforcement or intrinsic reinforcement to the matrix of the solder alloy in order to improve the properties of the existing lead-free solder. Okay, so as you can see, from this table, this is the ceramic reinforcement material that had been used by previous research. And from this list, we can see that there's still no research that carry out to investigate the effects of geopolymer ceramics to the lead-free solder, and especially to Z305. So, as I mentioned earlier, there are some drawbacks related to Z305, which is poor formation of IMC at either at the solder bar or at the interfacial layer. And these drawbacks can lead to some problems, which are rapid growth of IMC, poor refinement of the microstructure, and this can lead to poor mechanical properties of the solder joint. Okay, as you can see, this is actually what happened in the Z305 solder joint. And this image is the cross-sectional view of Z305 solder joint. And as you can see, this is the formation of a large primary IMC in the solder joint. And actually, this large IMC is very brittle. So, and then the size of this large IMC is quite big, and its formation is nearly half of the overall solder joint. So if this large and brittle IMC form in our electronic device, can we still maintain the reliability of the electronic device? Of course, the answer is no. Therefore, I introduced Z305 composite lead-free solder with the addition of kaolin geopolymer ceramic as the reinforcement material that I hope that it can improve the properties of the solder itself. So why we use kaolin geopolymer ceramics? Firstly, of course, there is still no research that had been working on investigate the reaction of Z305 with the addition of geopolymer ceramics materials. And then secondly, because kaolin geopolymer ceramic is actually one of the clay-based material that can have better performance as the ceramic. So therefore, this study is aimed to determine the effects of various weight percentage of kaolin geopolymer ceramic addition, especially on Z305 lead-free solder in terms of their microstructure formations, thermal properties, and the mechanical properties. Okay. And then this is the methodology that I had been used in this study. Firstly is the start with the fabrication of kaolin geopolymer ceramics. And then we go for fabrication of the composite solder with various addition of kaolin geopolymer ceramics. And to fabricate this composite solder, we use powder metallurgy method. And then this sample will undergo reflow soldering on the copper substrates. And we characterize the sample based on their microstructure, thermal properties, and mechanical properties. Okay, for the current finding, firstly is based on the microstructure of the sinter bulk solder. Okay, as you can see from figure A, this is a set 305 without the addition of kaolin geopolymer ceramics. And then from the figure B until figure E, you can see this is the microstructure for the set 305 with various addition of kaolin geopolymer ceramics. And as you can see, there is a particle grain boundary, and along this particle grain boundary, there is a black particle, which is the kaolin geopolymer ceramics that we added. And as this distribution of kaolin geopolymer ceramic was at the grain boundaries, it able to hold the grains, and those can retard the dislocation motion. Therefore, when this happens, it can improve the mechanical properties of the solder, especially for the hardness of the solder itself. The microstructure of the reflow solder joint. Okay, as I mentioned in the methodology part, after fabrication of the composite solder by using powder metallurgy, this solder will be reflowed in reflow oven on the copper substrate, as you can see here. And then this is the microstructure that we get after the reflow soldering process. And the microstructure consists of eutectic area and also beta thin area. And in this eutectic area, actually there are intermetallic particles that are dispersed throughout this area. And then from figure A, this is the microstructure of the reflow. So SAC 305 or set 305 without the addition of kaolin geopolymer ceramics. And figure C is the microstructure for set 305 with the addition of 0.5 weight percentage of kaolin geopolymer ceramics. And the figure below is actually the threshold image that we use to calculate the area fraction between these two areas. And then figure, and all this is the microstructure for set 305 with different weight percentage of kaolin geopolymer ceramics. And actually, for a good solder alloy, they need to have a very fine microstructure. What I mean by the refined microstructure is when they have lower fraction of beta thin area and also higher fraction of the eutectic area. Okay, as you can see from this illustration diagram that I've made, this is for SAC 305 without kaolin geopolymer ceramics. As you can see, this part is the having higher fraction of beta thin area, and this part having low fraction of the eutectic area. And actually the gray part here, you can see here, this is actually the IMC, the MC particles. And then for the set 305 with the addition of the reinforcement, you can see there is a lower fraction of beta thin area, this part, and then higher fraction of the eutectic area with smaller IMC particles. So by using the threshold image I mentioned just now, we can actually calculate the area fraction between these two areas. So from this graph, we can see that with 1.0 weight percentage of kaolin geopolymer ceramic, showing the best refining of the microstructure as compared to other weight percentage. And this can be concluded that the addition of kaolin geopolymer ceramic are able to add as additional nucleation sites. Okay. Next is for the interfacial intermetallic layer thickness. So as I mentioned in the methodology part, after fabricate the composite solder by using powder metallurgy method, we need to reflow the solder on the copper substrate in a reflow oven. So when we reflow the solder on the copper substrate, there is a formation of the intermetallic layer between this solder. As you can see from figure here, there is a formation of intermetallic layer between the solder and also the copper substrate. Okay, for a good solder joint, we need to have a very thin intermetallic layer thickness, and based on this graph, we can see that 1.0 weight percentage of kaolin geopolymer ceramic give the thinnest IMC, and this can be said that addition of kaolin geopolymer ceramic can inhibit the dissolution of the copper, since the formation of this IMC is actually by dissolution of copper to the solder part, and they react together to form this intermetallic layer. Okay, next is the thermal properties. Okay, for the thermal properties, we analyze based on the melting temperature and also based on the undercooling value. So actually, if we want to form a composite solder, the melting temperature of this solder should not significantly change the melting temperature when compared to set 305, which is without the addition of kaolin geopolymer ceramics. As you can see from this table, as we add various percentage of kaolin geopolymer ceramics, there is no significant change in the melting temperature, which is good for a composite solder. And then for the undercooling value, we need to have a very smaller value of undercooling, and based on this graph, we can see that 1.0 weight percentage of kaolin geopolymer ceramic give the lowest undercooling value, and when we have lowest undercooling value, we can promote for the faster solidification process, and this faster solidification process can refine the microstructure of our solder. And then for the mechanical properties, we analyze based on the shear strength of this solder, and again with 1.0 weight percentage of kaolin geopolymer ceramic, it gives the highest shear strength as compared to the other weight percentage. And actually, this highest shear strength was contributed due to the dispersion strengthening that occur in the solder alloy. And then this is the shear fracture mode for this composite solder. As we add various addition of kaolin geopolymer ceramic, we actually can transform this brittle surface or brittle fracture mode to the ductile fracture mode with formation of smaller dimple. And to conclude my presentation today, the addition of various weight percentage of kaolin geopolymer ceramics into set 305 actually can improve the microstructure, thermal properties, and also the mechanical properties of the solder alloy, or the or set 305 solder alloy. And I also can conclude that with the addition of 1.0 weight percentage of kaolin geopolymer ceramics, give the optimum value of the addition. And I think that's all from me, and thank you for your attention.
Thank you very much for your presentation. Look in the chat room, there is a question there from Professor Doro Burdofos, which asks you about where can be used this type of materials.
Okay, this material, this composite solder can be used in any soldering process, especially when we use reflow soldering as suggested by National Electronic Manufacturing Initiative just now.
Thank you for the question. Thank you for your contribution to our conference. Wonderful presentation, and I hope to finalize your research with your PhD thesis.
Thank you.
Good luck. We move further to next presentation, which is entitled Copper Sulfate Pentahydrate Target Behavior during Pulsed Laser Deposition to produce dichroic coatings for beam splitters, presented by Alexandru Cocean. Good morning, good afternoon, a little bit. Alexandru, hello. Please, you can share the screen, you can start the presentation.
I think.
Excellent, please.
Hello to everybody, and I want to thank you to the organizers. I'm going to present the study, copper sulfate pentahydrate target behavior during post-laser deposition to produce dichroic coatings for beam splitters. The study was conducted in ICIR laboratory. Director, Professor Silviu Gurlui. The aim of this study was to investigate the thermal effects of the pentahydrate copper sulfate under the laser beam irradiation and the potential to produce copper-based coatings on beam splitters, but also copper-based compounds for thin films to use on medical and protection masks. The COMSOL simulation was performed in order to obtain information about the thermal conditions developed on the target for preliminary estimations. The method used was post-laser deposition using the installation in the ICIR laboratory, which includes the laser YAG 981E ER10 laser system, and the parameter used was a 10 nanoseconds pulse width, a 542 nanometer wavelength at 45-degree incident angle, with a 10 Hz pulse repetition, with 346 micrometers pulse spot radius, with a fluency of 25 joules per square centimeter. The pressure in the chamber was 3 times 10 to the minus 2 torr. The COMSOL simulation was used to estimate the thermal conditions at the surface of the target, and the simulation, the model, the mathematical model, was designed and implemented in the ICIR laboratory. The study, the COMSOL simulation study, produced the phase diagrams listed, and the decomposition steps were estimated based on the simulation. First step would be the loss of water from 383 Kelvin to 923 Kelvin, as can be seen. And the second step was led to the decomposition of the copper sulfate. And the reaction is listed below. The mathematical model is already published. In the right is a diagram of the of how the irradiation looks from above, which has a decomposition area and a water loss area. The decomposition area is about twice as big as the water loss area, which leads us to expect a greater concentration of copper oxide due to decomposition, but also copper sulfate from the edge due to thermal effects and melting of the clusters and vaporization. Plasma temperature temperatures are achieved 10 to the 4th Kelvin order, which leads to further breaking of the copper sulfate, which leads to and copper oxide, which leads to further recombinations, as will be seen further. In the FTIR analysis, we can see the difference between the copper sulfate and the copper sulfate deposited on the film, which can be noticed around here. Copper hydroxide, which resulted from the recombination from plasma, and hydrogen sulfate, which again resulted from the recombination. And also hydrogen sulfate is a gas, so it can only exist on the surface of the film if a metal is present, in this case copper. Other bands are for water, and also copper oxide is present, can be seen as a peak. That's what I said. The optical properties of the film were also studied with UV-Vis through reflection and transmittance, and can be noticed that the same wavelength was used, but on different areas, has different intensities, which proves the fact that the concentration is different on the film. It's stable what I said. And also can be noticed in transmittance. The leaf spectroscopy was conducted with the same laser at 10 nanosecond pulse width, 10 Hz repetition, and 150 millijoules. And it can be noticed that on the left hand, it leads towards copper, the fluorescence. And on the right hand, it leads towards on the left hand sulfur dioxide and the right hand the copper fluorescence. And what else can be noticed is the fact that the two lines have different intensities. The black one is for glass and the red one is for hemp. Hemp also absorbs some of those substances, which leads to a lowering in intensity. It's what I said there, plus the radicals and the towers can be noticed. The same images of the film show that the film has a granular structure, but it's somewhat uniform, which also helps for the necrosis, the layer. the EDX structure shows the same, plus a somewhat uniform distribution of the compounds. It can be noticed that copper is one of the most abundant material in the layers, and sulfur. And the concentration differs from glass to hemp. The conclusion is that you can achieve a dichroic beam splitter from a copper sulfate target without using any intermediate gas, and with careful changes of laser parameters, films can be tuned to specific needs. Such coatings find a large number of applications from optics, electronics, to medical and composite materials. Due to important content of copper, film makes them suitable for uses where copper is required to be added on different materials, such as textiles, in producing composite designs for masks and other equipment wear for medicine. Copper is a virucide. As a commentary.
Thank you.
Thank you for your attention.
Thank you for your presentation, for your contribution, oral session. And I saw that in the chat room there are no further questions, so we move on to the next presentation. Experimental investigation on the development geopolymer paving blocks using Romanian local raw materials, recorded by Adrian Lăzărescu.
Good day, ladies and gentlemen, and thank you for being here. Hope you're all okay. My name is Adrian Victor Lăzărescu, and I'm currently working as scientific researcher at Nir Durban in Cerc, Cluj-Napoca branch in Romania. And today I will present experimental investigation on the development of geopolymer paving blocks by using Romanian local raw materials. Today's presentation is structured in 4 main sections, each one of them pointing out several key steps which led us to our final conclusion and perspectives about the development of geopolymer paving blocks. The benefit of recycling industrial byproducts in the construction industry led to growing interest in exploring and potentially exploiting these byproducts in the context of sustainable development and also in creating new materials. Geopolymer cement is the new type of cement that uses a different chemistry to the one found in traditional ordinary Portland cement. The particular procedure in which an alkaline liquid generates the solidification of fly ash powder when mixed together is represented by the alkaline activation. New types of binding materials could be obtained by using this procedure, and consequently new building materials when aggregates are incorporated in the binder, creating an alternative to traditional concrete and cement-based composites. As you can see, there are a lot of power plants in Romania that generate electricity, therefore a lot of fly ash. Only in 2017, this particular power plant generated nearly 650,000 tons of fly ash and nearly 100,000 tons of industrial waste. Only few of the total quantity of the resulting waste was reused in different fields, but with 565,000 tons per year of unused waste, it is still a problem in terms of environmental pollution. Preliminary research on the development of geopolymer paving blocks emerged from the results obtained on alkali-activated geopolymer paste. Based on results regarding physico-mechanical properties and several parameters that influence them, the transition to geopolymer concrete was achieved. As I mentioned, results obtained on alkali-activated fly ash-based geopolymer paste produced using Romanian local source materials created opportunities for further research to continue. By modifying the variables and ratios of materials used in the production of geopolymer concrete, necessary data was obtained on the parameters that influence this type of material, and our aim was to discover its possible directions of applicability and to present preliminary results. By using the full information on the production of geopolymer paste and concrete, as well as on the basis of the obtained results, a trial and error experimental research was built with the aim of producing geopolymer paving blocks. Low calcium fly ash from a power plant in Romania was used as main raw material for the production of the geopolymer paving blocks. Its chemical composition was established to X-ray fluorescence methods. A combination between sodium silicate solution and sodium hydroxide solution was chosen as alkaline activator. Natural aggregates, granular class 0.4 mm sand and 4.8 mm coarse aggregates were used in this study to produce the geopolymer paving blocks. In order to study the mechanical properties of the alkali-activated paving blocks, the following preliminary mixtures have been produced, considering the following parameters as constant: alkaline activator to fly ash ratio, sodium silicate to sodium hydroxide solution ratio, and sand to coarse aggregate ratio. The technology of producing geopolymer paving blocks was based on the principles already set out for the production of the alkali-activated geopolymer concrete. Initially, the sodium hydroxide solution was produced by dissolving the sodium hydroxide pearls in water until they were completely dissolved and the desired molar concentration was achieved. After 24 hours, the sodium hydroxide solution was combined with the sodium silicate solution at the specified ratio. The sand and the coarse aggregates were mixed together at low speed for 30 seconds. The necessary amount of fly ash was then added, and the dry raw materials were mixed together for another 30 seconds. After adding the total alkaline activator quantity, the mixing was continued at low speed for another 3 minutes. The mixtures were then casted into polypropylene molds with the corresponding 5-minute vibration, and the 70 degrees Celsius for 24 hours heat treatment was started. After demolding, the geopolymer paving blocks were stored in the climatic chamber, and the tests for their mechanical properties were determined at the age of 7 days. Here are some pictures from the production of the alkali-activated fly ash-based geopolymer paving blocks. The research initially focused on preliminary evaluation of the physical, mechanical, and durability characteristics of the obtained products for the study of their potential different areas of applicability. All the tests were performed according to the specific norm for concrete paving blocks, which specifies the materials, characteristics, conditions, and methods of testing the paving blocks. And it's applicable for the use of pedestrian, vehicles, bicycle lanes, parking lots, roads, and so on. The 7-day compressive strength of the geopolymer paste, produced using the same materials and the same mix design ratios, was considered relevant as testing age for the evaluation of the above nominated parameters of the paving blocks. Total water absorption has been determined by submerging the test samples in water at constant temperature until they reached constant mass. Subsequently, the paving blocks were placed in the oven and dried to reach also constant mass. Water absorption of each paving block was expressed according to the standard as a percentage by mass according to the equation. The geopolymer paving blocks freeze-thaw test specimens were preconditioned and then subjected to 28 freeze-thaw cycles, where their surface was covered with a 3% sodium chloride solution. After carrying out the 28 cycles, the exfoliated material was collected from the surface of the specimens and the mass lost per unit area was calculated. For the determination of this parameter, 70 per 70 millimeter cubes were used, cut from the geopolymer paving blocks and placed on the BOEM abrasive disc. Before the test and every 4 cycles, the test specimens were weighted. Test specimens were tested for 16 cycles, each consisting of 22 full rotations of the abrasion track. After the end of the cycles, abrasion was calculated. Unpolished slip resistance of the geopolymer paving blocks has been determined by using a test equipment consisting of a friction pendulum. At the pendulum swing, the force between the cursor and the test surface was measured by using a graduated scale. In order to determine the tensile splitting strength, the geopolymer paving blocks were placed in the testing equipment in a special device for the tensile splitting test, according to the specifications of the standard. The splitting load was applied progressively until the paving blocks were broken and the force was measured. Overall, the obtained results on the nominated parameters confirm the ability of the geopolymer paving blocks to comply with the mentioned standard, demonstrating the possibility of their use as paving elements in the construction material industry. Moreover, by optimizing the mixtures, improved performance can be achieved. The presented results contribute to the necessity of ongoing and up-to-date research on the identification and exploitation of the various Romanian sources of byproducts in order to produce alkali-activated geopolymer paving blocks. Besides the economic advantages, an important aspect is the ecological one, namely the reuse of industrial wastes and byproducts into the economic circle. Likewise, total replacement of cement in innovative, smart materials with low carbon dioxide emissions. Further similar studies will be performed by optimizing the mix design ratios for the production of geopolymer paving blocks in order to obtain the confirmation of the present conclusion and to demonstrate the viability of the material. Current research results are subject to 2 patent applications, one for the alkali-activated geopolymer binder, respectively one for the alkali-activated geopolymer prefabricated elements. This paper was supported by the program Research for Sustainable and Ecological Integrated Solutions for Space Development and Safety of the Built Environment with Advanced Potential for Open Innovation EcoSmart Cons, which was financed by the Romanian government. Thank you very much for your attention. And here are our contact details if you want to meet our team. Until then, thank you again and stay safe.
Okay, thank you for the presentation. Hello, Adrian. I think you are with us.
Yeah, can you hear me?
And you have a question here on the chat room. Is on behalf of Professor Mustafa from Malaysia, which asks you, how about compressive strength of these materials? And what of molarity of natrium hydroxide that you used?
Yeah, so hello everyone again. And first of all, I would like to say on behalf of myself and my colleagues from NIR Durban in Cer Cluj-Napoca branch that we miss you and we miss being in Iași and hope to see you all soon. And thank you, Professor Mustafa, for your question. So in terms of compressive strength of the concrete that we used producing, so yeah, I see that you, sorry, so hi. So we know each other.
Okay.
So in terms of compressive strength of the concrete that we used in producing the paving blocks, for this particular mix design, we obtained like 35 megapascals for the compressive strength. And in terms of molarity, for this mix design, we used the 10 molar sodium hydroxide solution concentration.
Okay, Professor Mustafa.
Okay, thank you.
Thank you.
Okay. Thank you for the question. Thank you for the answer. Thank you for your presentation.
Thank you very much and be safe.
Thank you. At home. Okay, we move on to the next presentation entitled A Model of the Functional Organization of an Art Cluster Based on a Revitalized Industrial Enterprise. Presentation recorded by Alexander Ivashko.
In many countries of the world, the phenomenon of space formation, which has been called the art cluster, has emerged and continues to evolve. However, a detailed analysis of the principle of organization of objects called in the literature as art cluster proves that they often do not fit the concept of an art cluster and is just simple combination of independent geometric premises. Moreover, despite the widespread use of the name art cluster in various sources, there is still no clear definition of the semantic content of this term relative to the word art and cluster. However, a new facts of life inspire the appearance of precisely these art objects, taking into account the development, including non-formal art movements, the need for new forms of job, and the artist's self-expression, especially since traditional art institutions no longer meet all the demands of society. The main problem is that industrial territories ended up in the central areas of the cities. In many cases, objects are monuments of architecture and belong to the cultural heritage, therefore must be preserved. The creation of a cluster on the basis of an industrial facility provides the creation of a model of their functioning, so internal relations between participants, because an art cluster is not an architectural object, but a form of space organization. Reprofiling an industrial architecture monument for an artistic orientation is a more gentle way to preserve the authenticity of an object than reprofiling it into a business center, hotel, or a shopping center. A new phenomenon always requires accurate determination of its nature and meaningful content according to the theme, the phenomenon, its definition. Well, the past decade, a fundamental new type of public institution called art cluster has emerged in different countries of the world. But at the same time, it is possible to use another name for such institutions, a creative space, which is a synonym to art cluster, so it's a broader concept. So according to explorationary dictionaries, a term cluster means the union of several similar elements which can be considered as an independent unit which has particular properties. There is a notion of economic cluster that provides for the structure of enterprises that are united by common material, financial, and informational issues, but the economic cluster does not function as a legal entity, and its structure does not provide for the unification for all participants by joint agreement. The notion of a cluster implies that all components with an art direction are interconnected, and the total effect of their joint action is several times greater than their effect of single components. Thus, the first defining feature of an art cluster as a specific artistic formation is not a simply a random collection of tenants carriers of certain types of artistic activity, but the presence of tenants or owners who work on one result, and their activities are interconnected. In order to create an optimal model of an art cluster, it should be emphasized that the result of its function is aesthetic or spiritual production, as opposed to material production. Today, more and more often, the term art cluster is applied and revitalized industrial facilities. The absence of clear criteria for the art cluster is a new type of public formation, leads to the fact that objects, which are essentially a simple collection of random tenants, begin to mean a common term. It should be understood that the art cluster, by its nature, given the semantic content of the terms art and cluster, is not an architectural object, but a way of organizing space for an art function based on interspecific relationships. Art formation can be represented in the form of hierarchical model, where the primary entity is an art object, on the basis of which art centers and clusters can be formed. The peculiarity of an art object is that such objects of several objects are separated and exist independently, and if located under one roof, they are easily replaceable. An art center is made up of several art objects united by a common infrastructure, and art cluster is a higher level of art formation. Their art objects are interconnected and aim at achieving a common result. Based on the combination of several art schemes, it is possible to create a mega cluster with a combination of several simple clusters and additional art objects related to the common infrastructure in its structure. Combining the concepts of cluster and art at the end of the 20th century, at the beginning of the 21st, is a fundamentally new phenomenon that arises in a cluster. Based on the combination of these two terms and the use of specificity of the objects, the concept of an art cluster can be briefly defined as follows. An art cluster is a multifunctional building with a combination of cultural and business trends designed for transformation in accordance with changing needs. A modern communication space based on creative expression, which consists of many different functions that have stable links and actively interact with each other. The total effect of the interaction of which significantly exceeds the effects of their interaction independently from each other. The effect of their interaction is separate from each other. Our clusters are positive things. In the process of creating a work of art, the principles of clustering become a way of organizing spiritual production. The process allows you to specialize and structurize individual creative processes and the activities of which are aimed at the synthesis of various types of art. In the production process of an architectural object, in addition to creating an architectural image in the architecture studio, both construction organization and artists are involved in the implementation. Our cluster quickly occupies the niches of houses and public institutions of the old type and combine creative hubs for creative self-expression, workplaces and event places. Such traditional institutions as cinemas, theaters, houses of culture, houses of creativity, school children's places are often perceived as outdated, do not fully meet all modern needs for creation, for creative and cultural development. Whereas modern people, especially young ones, seek above all favorable conditions for self-expression and development of their inner world by the means that everyone has the opportunity to choose on their own. At the same time, despite the extensive use of the term art cluster, not all revitalized objects with an art functions are art clusters. It is possible only when all the art parts are interrelated, work for one's corporate result, and enhance each other's effectiveness. In the analyzed objects, there is an artistic function, but there is no conscious interaction between the various artistic components, and the process of such education becomes uncontrollable. Therefore, it is ineffective with no time. So, the analyzed objects are not art clusters, but only art structures with no cluster signs. The main mistake is that an example starts to be called as an art cluster if at least one artistic component is present in the objects, forgetting about the word cluster, the interrelationships. The principal functions of an art cluster are the following: the art function, of course, functions that supplement the main functions, at least galleries, exhibitions, and auxiliary functions that are not in contrast to the principal and relative functions and can functionally be combined with them. Okay, coffee houses, breweries, and so on. The following links between the function areas of the art cluster are possible: workshop, exhibition and gallery sales, popularization and involvement of the general public.
Hello, my name is Dominica Scricariu and I...
Okay. Thank you for the presentation. We move to the next paper, which is entitled Designing Concrete with Self-Healing Properties Using Engineered Cementitious Composites as a Model. Recorded presentation by Ana Maria Catalina Mircea.
Properties. Hello, my name is Ana Maria Catalina Mircea, and together with my colleague Tudor Toader, we've designed a concrete with self-healing properties, using as a model the engineered cementitious composites. Both of us are working at National Institute of Research and Development, Urbani Cerc, Cluj-Napoca branch. Because nationally and internationally, a large quantity of products that are not used and they are considered waste pollute the environment, incorporating them into new materials that are innovative, environmentally friendly, is the best way. The experimental study was based on the identification of those materials and at the evaluation of their performances and their compatibility. The engineered cementitious composites materials are an assembly between two or more materials, a combination that generates different and significantly superior characteristics than those of each individual material. A reinforcement component is added to the matrix, also called to the basic component, and improves the mechanical and self-healing properties. For this concrete, the constituents that we've used are a fine silica sand as an aggregate, a normal cement, a Portland cement, PVA and PP fibers, a normal water, a superplasticizer additive, and as an addition, the limestone slurry. In the mixture, some parameters vary, like the amount of water or the additive, the fly ash types, and the fiber types. The components from a local source were the aggregates, which mean the silica sand, with a granulation of not more than 0.3 millimeters, the fly ash, and the addition, which is the limestone slurry, which is considered chemically inert and without a pozzolanic activity. The binder was a usual cement, Portland cement. The additive was a water reducer that allowed a considerable reduction of the specific ratios. And for the fiber characteristics, we can say that they have a tensile strength about 2 or 3 times higher than the concrete. And also, the elasticity model is higher than the one of the concrete. The chemical composition of the fly ash is presented in the table 1. And in the figure 1, you can observe the components for the mixtures. For the compositions, we've determined the characteristics in hardened state as follows: the density after demolding and the density after 28 days, the mechanical resistance, and the evaluation of the repair potential at different ages. Those ages at which we've tested the specimens were 28 days, 56 days, and 90 days. The determinations were made according to the standards. On the prismatic specimens for the tensile strength, for the compressive strength on the halves of the prismatic specimens, and the repair potential was tested on the coupons. As you can see, as the age grows, also the compressive and the tensile strength are growing. For compression, we've obtained not less than 35 megapascals at the 28 days. And at the 90 days, it's almost double. Also, the same thing is for tensile strength. The values grow at almost double of the ones that we've obtained at 28 days. Concerning the cracks or the micro cracks, the specimens were tested at 28 days and they were microscopically evaluated and then supposed to 28 self-healing cycles, which include 12 hours are immersed in water and 12 hours are exposed in air in the laboratory conditions. After the 28 cycles, the specimens were re-evaluated at the microscope. And as you can see in figure number 4, the cracks were closed, partial or all of them. In the table 2 is the micro cracks evaluation. As you can see, 75% were totally closed and the rest were partially. The conclusions are very clear. 75% of the cracks and micro cracks were closed totally. The strength increased from 28 days to 90 days with almost double, both in compression and tensile strength. The next step in the research is to make a transition from the small mortar castings to large castings, which means to concrete. For the large castings, we've observed that the composition needs a reassessment by reducing the water and the additive percentage. The aim is to obtain a concrete with self-healing properties, at least with the same characteristics as the one that we've obtained in engineered cementitious composites. Thank you for your attention.
Thank you for the presentation. I saw that also there are no questions in the chat room. So we can move to the next presentation, which is made by Bianca Iulia Ciubotaru, and the presentation is entitled Comparative Study on the Characteristics of Silicon Synthetic Elastomers Used in Dental Impression Techniques. Hello, Bianca. Please open your microphone. She was with us in the, as a participant. Maybe she will come back. We'll put her live. Meanwhile, we'll skip it and we'll go to the next presentation from the oral presentation session. So on the security of the software-defined network used by a smart city, record the presentation by Luminița Scripcariu.
Hello, my name is Luminița Scripcariu and I will present you today the paper entitled On the Security of a Smart City SDN-based Network. The content of the paper, first of all, the introduction, then the concept of software-defined networking. We continue with the security risk and analysis for a smart city network and security measures for the smart city network. At the end, we'll present the conclusions of the paper and references. Okay, let's begin with the introduction of this article. Think about a large city. If we want to transform it into a smart city, then the communication network of it interconnects a lot of devices, like smartphones, like wireless sensors, like, I don't know, smart TVs, traffic lights, digital displays all around the city, and so on. And all these devices should be secured. Information sent by the network should be correct and complete. Otherwise, the life of the city can be seriously compromised by cyber attacks. For example, the public transportation system can be disturbed. The traffic information on highways can be false, or location services for emergency crews can be errored. So we have to ensure the security, a complete set of security services for this communication network. A good choice, a good solution for to secure this is to enable the software-defined networking that centralize the control of the entire network. Also, the network architecture and the management of the network is simplified by using SDN. Let's present some concepts of SDN. A traditional communication network, metropolitan area network, includes a lot of routers involved in packet transportation, with a mesh topology with a lot of links between them. These routers usually are very complex and the configuration of them is a little bit difficult, but this is not the main point. It is about the security of the network, and it is difficult to ensure it in a mesh topology. On the other hand, the software-defined network represented with the architecture presented on the left side has a separated control plane with network controllers and distinct data plane with forwarding devices like switches and routers. The network controller is connected to the management plane, and that includes a lot of applications. And in this case, we are interested in routing, in network virtualization, in access control, in network monitoring or attack detection. But of course, there are a lot of other applications like web browsers, web applications used a lot by nowadays users. So instead of L3 routers and switches, SDN uses network controllers and easy to configure forwarding devices. But not only these are in the network. We need a lot of servers for, let's say, web application, file transfer, email services, database management, DNS, logging history, user authentication, and so on. So we have we need a lot of in-house servers usually, but a good option is to use cloud servers instead of in-house servers for the smart city. Also, we need to ensure the energy supply for 24/7 with no interruption if we want to have a good functionality of all services in the smart city. Also, big data is collected and transmitted and processed. So we need broadband, a broadband network to communicate. We need high storage capacity. We need a lot of processing resources for the smart city network. Planning this network is difficult because usually cities have traditional structure, have historical sites, old buildings, so we have to keep all this unchanged, okay? Not visible transformation should be done, but in the same time we have to have smart city services available all over the area. So let's speak about the security risk analysis for the smart city network. When we speak about a smart city, we need to think about a lot of services in many fields, such as traffic control, e-health, emergency services, environmental monitoring, e-commerce, event advertising like sport events, think about this. Then we have a lot of smart homes connected to the smart city network, and also you have to think about the people's safety all over the place. A lot of cyber attacks can be launched in the smart city network in order to block communication, to steal information, to insert false data, to take control over the devices, over the services, or over the entire network. A lot of data has to be protected, like personal data and also public information. All these are stored in large databases and usually are accessed via web applications. Web applications must be developed securely to send information to people on their smart devices or on public devices located throughout the city. Also, large public displays can offer visual information to a lot of people on the street. Audio information can be delivered on different places of the city. Many sensors and video cameras installed in the city send the data to the city servers using the SDN-enabled network. Actuators, which are the main component of the smart city network, are used to turn off or on different equipment all over the area. So all these devices and applications should be secured because they are exposed to a lot of risks of being attacked by hackers. The risks of a malfunction exist in any point of the network, but for a systematic analysis, we need to use the onion security model, which includes the physical access layer, the logical access layer, then the service layer, application layer, and finally the information layer. Having this security model in mind, let's present the security measures for a smart city. First of all users and employees should be aware of the risks and of the consequences of cyber attacks. It's important to secure every device, to configure properly users' accounts, to secure all communication links and equipment. Digital certificates should be installed on all devices connected to these smart cities. Also, the security of personal device is the responsibility of the owner. So it's important to enable automatic software update in order to run the latest version of software with the best security facilities. Users' accounts should be configured based on the principle of least privilege, which is essential in order to avoid potential damages produced by people with or without an intention. Mutual authentication is also a good solution that avoid masquerade attack and protect users' credentials. Virtualization, like virtual private networks, virtual machines, virtual containers, are a good option to separate traffic between different customers, between different companies, and to ensure authorized access to all services. Message authentication is an important aspect, and digital signatures are a solution to, and also message authentication codes if we want to be sure about the authenticity of all messages. So don't forget that the security is the responsibility of every participant to the communication. So all of them has to ensure the confidentiality of data, the integrity, data integrity, and service availability based on the CIA principle, by encryption algorithms, by different security measures. SDN centralizes all these security techniques. Don't forget about the backup solutions for all databases, for all communication links, for everything, hardware and software. Monitoring and logging history should be continuously analyzed. A security incident in event management system should be used for a smart city network as a whole. It's a good option to use machine learning based security mechanisms and also artificial intelligence algorithms that create behavior patterns and can identify different security incidents. A monitoring, alert, and interventional security system is needed in order to identify in real time all the attacks. A systematic security plan should be developed if we want to have the availability of the services all the time. Let's go to the conclusions. So the design of the smart city communication network is a very complex task with a lot of responsibility regarding the possible consequences of malfunction and disruption. SDN-based network is a very efficient solution because it centralizes everything, including control and security of the network. A lot of methods for security can be applied, like continuously monitoring, real-time alerts, prevention mechanisms, and of course efficient interventional countermeasures that ensure the security and the availability of the SDN-based network for the smart city. These are the references of the paper. Thank you for your attention.
Thank you very much for the presentation. If there is any comments from Lunica Scripcariu or not, so there is no question in the chat room. So we move to the next paper. Oceanographic research and recordings made on the northwest coast of the Black Sea. The paper recorded by Andra Teodora Nedelcu.
Hello, my name is Nedelcu Andra, and in collaboration with Dinuato Direse and Nicolae Buzbuchi, I will present you the paper entitled Oceanographic Research and Recording Made on the Northwest Coast of the Black Sea. Regarding the content of the paper, I will present you a brief introduction about the Black Sea Basin, then the first part, second, and the third part of the experiment, conclusion, and finally the reference used for this paper. The Black Sea represents an inland sea situated between Europe, Anatolia, and Caucasus, named in oceanographic literature such as a small-scale model of the ocean. In the southwest, it connects with the Marmara Sea using the Bosphorus Strait through a 0.7 to 3.5 narrow channel with 31 km in length and a depth between 39 to 100 meters. The aim of this paper is to provide an overview of general underwater circulation feature in the northwest coast of the Black Sea Basin. In order to achieve this, during 1 year were analyzed data coming from different stations near the coast. First is presented a general description of circulation patterns in the Black Sea area. All the reference points have registered during 1 year data information about the water current amplitude, water current direction, and water pressure. These data were analyzed and compared with in situ data obtained using current method along the Black Sea. The current velocity depends mostly on the point's location. The objective of this paper is to convey an image of general underwater circulation of masses featured in the northwest coast of the Black Sea Basin. In order to achieve this, during 1 year were analyzed data coming from different stations near the coast. The position of each station, each buoys, are presented on the slide in table and a figure. Each station belongs to Research and Development of Marine Geology and Geoecology, a Romanian Institute of Geology and Geoecology. In August, the station have registered the following data presented in table on slide. For all 3 stations were calculated average, maximum, and minimum value regarding the water current amplitude, water current direction, water pressure, and water temperature. According to table, the average water current amplitude was recorded in August at station 2, 175. We have a general water current direction between 170 to 220 degrees. Looking to the table, the water pressure doesn't register different value for two stations, such as the water temperature. Take a look at the station 1 and station 3. The second part of study during 2018, I executed two measurements using current meter model 106. Also, the paper presents an overview of different characteristics of underwater environments, such as determination of direction and current value, temperature, conductivity, pH, redox, density abnormality, profile salinity on water columns between coastal area from Constanța Harbor to Eforie Harbor in the northwest coast of Black Sea Basin. The instrument used for both measures is designed to determine real-time water parameter value. It works at every 1 second cycle, at which time only the compass path value is recorded. To do this, the eastern and northern speed are calculated and then summed for an average period. Additional parameters that it offers are temperature and pressure. Each measurement started at a depth of 2 meters and ended at 6 meters, except for the first measurement where the depth at sea was 3.25 meters. Depending on the depth at which the simulation is executed, the current meter model 106 has different value on the direction and velocity of the current. Measurement made with the flow water took place in 2 stages. The first stage during the summer, when according to graphic 1 the current velocity is relatively small, about 0.02 meter per second. The second stage of the recording was carried at the end of the summer, when the current speed reached the maximum of 0.08 meter per second. The device recorded data from a depth of 2 meters to about 6.5 meters. The last part, the third one, presents the measurement obtained from Maritime Hydrographic Directorate. The Maritime Hydrographic Directorate used to measure oceanographic parameters, oceanographic sensors like CTD, Valenport current meter, Valenport magnetometer, sea spy, marine magnetics. The Maritime Hydrographic Directorate performed 10 ACM station and 4 CTD station for which were determined different characteristics of the marine environment. The position of each station is presented on slide. We determined the direction and current value, temperature, conductivity, pH, redox, density, anomaly, salinity on water columns with a height of between 5 to 25 meters. In this case, the measurements were performed from the figure in a position latitude 44 degrees 03 minutes 0.6 north and longitude 28 degrees 40 minutes 0.5 east. In this point, the velocity varies between 0.04 meter per sec to 1.54 meter per sec. The salinity between 16.1 to 18.1, and the water temperature varied between 5.56 degree at the bottom to 16 to the sea surface. From the station ACM12, the velocity varies between 0.10 meter per sec to 1.20 meter per sec with a general current direction of 183 degree. The characteristics of the data recorded by station ACM2.2 are velocity varies between 0.10 meter per sec to 1.20 meter per sec with a general current direction of 183. In case of station CTD and ACM2.1 were obtained the following data. Velocity vary between 0.04 meter per sec to 1.74 meter per sec. Salinity between 15 to 18. Water temperature vary between 5 to the bottom to 17 at the surface. In conclusion, it can be concluded that during the summer month there is a strong stratification of the active layers from the sea and that the surface layer is very sensitive to the speed, direction and duration of the wind the Romanian seaside. The measurement of data regarding the influence of the current on the Romania coast from Capul Milea to Mangalia and the records presented in this paper ensure capitalization perspective on the following direction. Methodology for optimizing coastal current measurement by providing specialized equipment, validation of experimental coastal current models based on preceded data or measurement performed in real time, and their inclusion in the training process of integrated navigation simulators, optimization the response in emergency situation or the management of intervention technique for special situation, oil spill or extreme events, operational and risk management by using navigation simulators or specialized equipment, meteorological instrument for the safety of shipping routes, loading or unloading operation, entry or exit maneuver from harbors. The reference uses for these presentations are on the slide. Thank you for your attention.
Thank you also for the presentation. So are no further questions in Zoom group chat. So I must to announce you that this was the last paper for the session 3 oral presentation, and the last presentation for the conference. So we'll take a break for around 10 minutes, and after that we will announce the winners for oral and poster presentation, and of course the closure of the conference. Okay, thank you all of you for the break granted to the organizing committee and for the scientific committee, which has to take some, already done some difficult decision. Ladies and gentlemen, we reach now the final moment at the International Conference of Innovative Research. For some conclusion, I invite Andrei Victor Sandu, which is the main coordinator of the Euroinvent, the main event which usually take place in Iași, to say some words as a conclusion. Please, Andrei.
Thank you very much, Professor Vizurianu. It's a great honor for us to have you all participated in our first virtual edition. Let's hope that will be the last virtual edition and to get back to our traditional kind of conferences where the chemistry bonding is different than the virtual one. Just a few ideas. We want to thank to all the participants. Some of you are participating also in the exhibition. I showed last on the camera our publications. I will show it now. This is the proceeding of the Euroinvent. The Euroinvent, the entire festival, because as I said at the beginning, Euroinvent means Invention and Research Exhibition, Conference on Innovative Research, Book Salon, Art Salon, and Workshop. And all these events together form the Festival of Creativity entitled Euroinvent. And we have this book, which is present digitally on euroinvent.org, with all the details from the conference, exhibitions, and so on. So this is volume 1 regarding the proceeding. Then we have the Book of Abstract. All these volumes have ISSN, so are registered and indexed. This is the Book of Abstract from the conference. All the presentations are here from keynote speaker, invited speaker, and regular papers and posters. And then another small workshop for the students that elaborated also a few articles that are published in this workshop. There was a great effort for all of you next to us that we are here standing behind our desks and making this possible for you to disseminate your latest results. We had these days amazing presentation from your side. We learned new things. We open new research ideas and hope also collaboration between our own countries presented here from Israel, Morocco, Malaysia, Bulgaria, Poland, Ukraine, and not only. So you did a great job in here. I'd show you, this is the Euroinvent medal, which is granted to inventions and research project. Okay. And before the final moment, just to say that it was very, very difficult to decide the award recipients. We had several proposals. We had to discuss also with MDPI, the publisher that granted us the money to give to the awardee. So now I will pass on the microphone to Professor Vizurianu, the chairman of the conference, to announce the grand winners. And be ready, like you say in a match, the rumbling now and ready for the main announcement. Thank you.
Thank you for such a wonderful presentation. And start the best presentation. And I must have mentioned that the best poster presentations selected by a scientific committee covers the topics of the conference and were based on original and unpublished work. So the winners for the best poster presentations, first of all, Ileana Mariana Mateș, Augustin Semenescu, Silviu Ionel Dumitrescu, Roxana Vidu, for the presentation, New Materials and Processes Developed for Cranioplasty. This is a scientific contribution award in the poster session. Next one, Kiseleva, Tarasenko, and Fedotov from Moscow, Russia. influence of primary power source and heat insulating materials choice for autonomous telecom unit container. And the last one, Vasile Soporan, Vescan Lehene Pădurețu Gabor, consideration regarding the recalibration of the manufacture of the castings from the perspective of the development of the circular economy. We are thank you, all of you, for all efforts to have also the poster presentation. And for sure, all the work posters were very well done. But as usual, we must choose the best of it. All the posters are online in the web page of the conference. Now for the best oral presentation, as we speak at the opening ceremony of the conference, the special award is in value of 500 Swiss francs for best oral presentation, which was granted taking into consideration the scientific content and presentation of the paper during session. Also, more important, is the winner has a free article processing charge in value of 1,800 Swiss francs for one article published in Coatings, a very important MDPI journal. And the winner is the paper presented by Laura Hroștea, improving the photovoltaic performance of PBDB TSF thin films by chemical sensitization. So is the granted the award and also the APC free of charge in Coatings. Laura, if you are with us, you can say some words, please.
Yes, I am. Do you hear me?
Yes.
I think my network connection it's too slow to send you a video.
We hear you very good.
But at least you can hear me.
Yes.
Actually, I want to thank you. I'm very surprised to to be the winner of this conference. I'm really exhausted. And I'm really enthusiastic to see the results in the end.
Okay. Thank you very much.
Thank you too.
And congratulations for your achievement. And we must keep in touch because we must provide you the money, and also to make an extensive presentation of your paper from the conference to be published, to be sent and published as a recommendation of scientific committee of the conference to the Coatings.
Okay.
As usually is a Q2 quartile journal.
Yeah. I was interested in that journal.
Okay. Okay, now also I want to thank the International Scientific Committee, all reviewers and organizing committee for their efforts. Also, I must mention some significant efforts done behind the screens on backstage, which were made by Andrei, Master of Euroinvent, Manuela, Master of Recording the Sessions, Dragos, Master of Book of Abstract, Simona, Master of Diploma, Doru, Master of Playing Video Files and Presentations, Diana, Mastering and Recording, and we trying to be everywhere at the same time. Thank you to Keynote and invited speakers for important and high quality presentations. Thank you to all participants to make special efforts to present in oral manner a scientific paper in a special conditions. Thank you for participants at the poster session, which are enriching the conference by their scientific contribution. See you in 2021, May 2021. Stay at home, take care, be safe. Waiting you next year in Iași. Thank you all.
Thank you.
And last moments, just enjoy from our brother Musu from Korea.
Câte vrea să știi ce s-a întâmplat, câte noapte am plâns de când ai plecat. Nu ce ți ne-a spus ultimul cuvânt și ne-am despărțit pentru vorba în vânt. N-am crezut atunci că din tot ce-a fost vom avea drum fără niciun rost. Poate nici nu știi cât am săpat să ne amintim tot ce am uitat. Cât vom alega pe pământ, vom minti mereu, suspinând în gând după aceea. Mă voi întoarce după aceea, sigur voi veni după aceea. Vom fi împreună din nou, primul nostru gând ne va regăsi plângând.
Thank you very much for everything. Hope to see you next year. And for the participants of the Euroinvent exhibition, tomorrow will be the ceremony, the announcement for the grand winners of the invention and project registration. Good luck to everybody. Take care, be safe. See you soon.